everyone, today's math problem involves Mr. Incredible and Jack-Jack, as well as Jack-Jack, 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 and Jack-Jack. Let me explain.
Mr. Incredible is left alone babysitting Jack-Jack when out of the blue, Jack-Jack clones himself, and Mr. Incredible is left alone with 9 Jack-Jacks. Mr. Incredible weighs one of the Jack-Jacks and, to his surprise, he only weighs 10 pounds. Mr. Incredible, however, knows the real Jack-Jack to be 20 pounds. Let's help Mr. Incredible. Using a weighing scale, suggest a method in which you can find the real Jack-Jack in the least amount of attempts. First off, let's use George Poya's 4 steps to problem solving, which is to 1. Understand the problem, 2. Devise a strategy, 3. Carry out the strategy, and 4. Look back.
Number 1. Understand the problem. We are trying to find the real Jack-Jack out of a group of 9. The real Jack-Jack is 20 pounds while the other clones are 10 pounds each. This means that the real Jack-Jack is heavier than all the other clones, meaning whichever side of the scale weighs heavier will have the real Jack-Jack.
Number 2, devise a strategy. Since we are looking for whichever side is heavier on a scale, we will need visuals to reference all possible outcomes for whichever side the scale tilts towards. Let's draw.
Step 3. Carry out the strategy. In the first weighing, let's divide all Jack-Jacks into 3 separate groups of 3. This will allow for us to quickly determine which group has the heaviest Jack-Jack. Label the group respectively, A, B, and C. Then weigh groups A and B and leave group C off to the side.
Outcome number 1. If A is heavier than B, the scale will tilt towards group A. Group A will have the real Jack-Jack because the real Jack-Jack is twice as heavy as the other clones.
Outcome 2. If B is heavier than A, the scale will tilt towards group B, and group B will have the real Jack-Jack.
Outcome 3. If A and B are equal in weight and the scale is in balance, then no Jack-Jack in those groups are heavier than the other, meaning they are all clones and group C will have the real Jack-Jack.
Let's apply what we know. So here, we see that the scale tilts toward group B, meaning as in outcome 2, that group B is heavier than group A. So the real Jack-Jack will be in group B.
Now that we know which group has the real Jack-Jack, we can easily find him. Label all Jack-Jacks respectively, 1, 2, and 3. Weigh Jack-Jack 1 and Jack-Jack 2 and leave Jack-Jack 3 off to the side.
Again, there are 3 possible outcomes. Outcome 1, if Jack-Jack 1 tilts the scale his way, we know Jack-Jack is twice as heavy as the other clones, so Jack-Jack 1 is the real Jack-Jack.
Outcome 2, if Jack-Jack 2 tilts the scale his way, Jack-Jack 2 is the real Jack-Jack.
Outcome 3, if Jack-Jack 1 and Jack-Jack 2 balance the scale, then the 2 Jack-Jacks are equal in weight, meaning Jack-Jack 3 is the real Jack-Jack.
Let's apply what we know. Here we see that the scale is balanced between Jack-Jack 1 and Jack-Jack 2, meaning Jack-Jack 3 is the real Jack-Jack.
Number 4, look back.
I never look back, darling. It distracts from the now.
We have to, Edna. It's part of George Poya's 4 steps to problem solving. We divided the 9 Jack-Jacks into separate groups of 3. We saw that group B was heavier than group A, meaning that group B had the real Jack-Jack. And we could go on to weigh that group to find the real Jack-Jack. We then proceeded to weigh each Jack-Jack in group B separately and found that Jack-Jack 1 and Jack-Jack 2 were equal in weight, meaning that Jack-Jack 3 in group B is the real Jack-Jack. This allows us the ability to find the real Jack-Jack in only 2 weighings.
Here you go, Mr. Incredible. We found the real Jack-Jack.
Mr. Incredible has time to clean up and put Jack-Jack to sleep before Mrs. Incredible comes home, thanks to our math superpowers and George Poya's incredible 4 steps to problem solving.